Hello, my name's Tim Shoebridge. I'm very pleased to be able to show you today a new piece of software that I've been developing over the last few months. It's a MIDI controller, a software MIDI controller of sorts. Now, let's talk about polychaining. Polychaining is something I really like to do with synthesizers. It's an awful lot of fun and it really does expand a synthesizer's capabilities. The problem with polychaining is that only a few synth manufacturers put that capability into their synthesizers, and when they do, it's a very bespoke technology. There's no standard. You can't just take any old two synthesizers and hope to be able to polychain them together. So that's what my piece of software, that's the problem that my software solves, is the ability to be able to polychain any instruments, whether they are hardware synthesizers, electronic keyboards, or even soft synths running inside your DAW. My software is called Polychain DIY, do-it-yourself polychaining. Let's take a look at how it works. Okay, so here is Polychain DIY. You'll see there's an awful lot going on there. There are lots of controls, but most of them are organized in rows. Each row represents an instrument that Polychain DIY can control. Now, when I say instrument, what I mean by that is synthesizer, sampler, groovebox, electronic keyboard, soft synth running as a VST in your DAW. As long as it's something that generates noise that you can play notes on, that you can play using MIDI and connect to on your computer, then Polychain DIY can control it. Now, Polychain DIY is a MIDI controller fundamentally, and like any other kind of MIDI controller, whether it's hardware or software, you have to connect it up in a certain way. So to show you what I mean, I'm going to put a graphic on the screen right now. You'll see there's a little keyboard at the top. That could be a MIDI controller keyboard, it could be any kind of MIDI device, it could be a sequencer, anything that generates note data basically. And that note data needs to feed into Polychain DIY. So Polychain DIY needs to have a MIDI input to receive that note data. And then what Polychain DIY is going to do is it's going to hand out note data to one or more instruments as it sees fit as you play. So it's going to have a MIDI out for each of the instruments that you want to connect to. Let me show you how we do that in Polychain DIY itself. You'll see here top right we have a MIDI in, and what I'm going to do is I'm going to hook that up to my Nordwave 2 keyboard that I've got right in front of me here. So that's how I'm going to play these synthesizers. And you'll see here I've got quite a variety of synths around me. Let's choose a few at random and play them and see how Polychain DIY works. So for my first instrument here, I'm going to let's choose Pulse 2. So that's my Waldorf Pulse 2. For the second one, let's choose this Tori's AS1 monosynth. Third one, I'm going to choose a polysynth, Jupiter X. I haven't got a Jupiter X, I've got a Jupiter XM, but that's the name of the USB driver. And it's right behind me down here, you can't actually see it. That's my little XM. And then for the fourth one, I'm going to choose this port here, port number 5. It's not obvious, but that should hopefully be the Behringer monopoly that I've got behind me here. If anything is not obvious here and you want to make it clear what instruments you've got set up, you can actually change these numbers to any text you like. So what I'm going to do here is, instead of that number 4, I'm going to put in here monopoly, so I can see that instrument number 4 is the monopoly. Now down the left hand side here there is an enable button, so we can turn off different instruments or temporarily if we don't want to hear them and try out different things. You can hold down the control key and you can solo different instruments, hold down the shift key and everything goes back on again. Let's just, before we do anything else, let's just play the keyboard and see what happens. So Polychain DIY is currently in a mode using an algorithm whereby it's going to sequentially go through each of the instruments in turn, hand out a note to each one in turn. You'll see here that there's a voice count. Now 3 of my synthesizers are monosynths. The Jupiter XM clearly is not a monosynth, although it could be in sort of mono mode at any time. But you'd set the number of available voices for each of your instruments, because the idea behind polychaining is to maximize polyphony. It's actually to sort of like use your instruments together as if they are one instrument, one virtual instrument, if you like, with maximum polyphony. So that's the whole idea. So you would set this voice count to be what you want it to be. Now, clearly I can play it very happily with just one voice, but I do believe that the XM is potentially up to 128 voice polyphony, I think. I can't remember. But you'll set it to whatever works for you with whatever you're playing. It actually can be very interesting creatively to minimize the voice count rather than set it to maximum all the time. I'm actually going to be only using 4 voices with the Jupiter XM because it's easier for me to describe and show and explain how the voice count and voice stealing stuff all works as we get into the different algorithms. So that's what we'll cover next. Okay, so while we've got Polychain DIY connected up to a variety of synthesizers, let's talk about the different Polychain algorithms that there are inside Polychain DIY. Now, we've come across one of those algorithms already. It's called sequential mode, but there are actually 4 to choose from, as you can see from this switch here at the top, P, R, S, and U. So we're currently on S, which is for sequential, and sequential, if I play one note at a time, you'll see that notes are handed out to each instrument in turn in strict sequential order. It doesn't matter what the polyphony of each of the instruments is, it's always that strict order. And it's a really nice mode to get some very predictable results when you're playing arpeggios or repeating sequences, something a bit like this, for example. So that is sequential mode. R is completely opposite. It's random. R for random. Random mode. Again, it doesn't matter what the polyphony is of each of the instruments. An instrument is chosen completely at random every time. So let's start off by playing one note. It is completely random, although sometimes it doesn't give that impression. It's completely random. So this gives a more interesting and less predictable, obviously, sort of like sound to arpeggios and to repeating sequences. So let me play that same sequence again. Like that. The next mode is P, and P stands for polyphony, and this particular mode is a mode which is going to maximize the amount of polyphony. And let's face it, you know, the main reason for polychaining different instruments together is to maximize or increase the amount of polyphony that's available to you. This is the mode which is going to take into consideration the available voices on each of the instruments that you have set here. So what we're going to find is that it's actually going to favor this Jupiter XM more than the other instruments because this has a higher voice count. It might not be particularly obvious if I just play one note at a time. It will become more obvious as I hold down notes and we start to eat up those available voices. Let me show you. It is favoring the Jupiter XM more often. In fact, it's actually 4 times more likely to choose it than the other ones. Now let's actually hold down some notes and you'll see what happens. See there, that it ends up utilizing all of those voices. You'll see there the active count is exactly the same as the voice count that I've set. One more mode for us to try out here, and it is U, and it's U for unison. And this again is a mode which will not take into consideration the voice counts of each of the instruments you've defined here. It's going to play all instruments with every note in classic unison style. So we get this. Very nice. Now obviously you can achieve that without using software like my Polychain DIY. You could daisy chain all of your instruments together and send them, you know, MIDI notes from your DAW or from your keyboard. You don't have to use polychaining software to do that, but it's a nice feature to have there. It can be very dramatic, and you can just set it with the flick of a switch. So the next thing I want to talk about with Polychain DIY is zones. Now this is where Polychain DIY goes sort of above and beyond what polychaining would normally do for you. Because what you can do with your instruments here is you can specify the note range, you know, along the keyboard where that instrument will be active, and you have got complete flexibility. There's no limit to the number of zones. Obviously there's a limit to the number of instruments you can have here, but they could all be in their own zone. You could have 8 zones across the whole keyboard, or you could have zones with multiple instruments in with polychaining going on, butting up against each other or overlapping each other. It's entirely up to you what you want to do. Now the way that you set a zone is you say, okay, well for the pulse 2 I want it to be in, say, the upper half of the keyboard, so I want it starting from the C here. So you hold down and press the key. It's as simple as that. Now it's going to go from C5 upwards. Let's say I want the Torize AS1 to go up to the C above it, so we'll have a little overlap region where they're both able to play. So we'll go with C6. So I'm going to limit the Torize, its upper note, to be C6. Let's have the Jupiter playing all the way across, and the monopoly, okay, well we'll have it maybe in this lower region down here. So we'll have it going from this C4 up to B4. I don't really know what I've done there, but let's find out how that's going to play. So in terms of the algorithms and how they will work, well, let's go to unison mode, because in unison mode we will be playing all of the instruments at the same time. Which ones we end up playing will really rely on the notes I'm playing and the zones I'm falling in. So if I play a really high note, it's choosing the Pulse 2 and the Jupiter XM, because remember the Jupiter XM is across the whole keyboard. The Pulse 2 is just up the top region. As I move down, now we come to C6 here, and it can now play the Torize AS1 as well, all the way till we get down to B, and now it can't play the Pulse 2 anymore, but it can now start to play the monopoly. So maybe it doesn't sound great using it in unison mode, but if we were to use it in one of these other modes, you'll hear that we get something a little bit more interesting. And while we're creating these zones, it's really useful to be able to transpose synthesizers around, so that maybe, you know, you want to put one of your instruments down the bottom range of the keyboard, but you don't want it playing low notes, you want it to play higher up the range. So we have a transpose function here, and we've got complete control of semitones all the way plus or minus 48 semitones. So that's a huge range in which to sit each of the instruments. And if you want the same instrument to be in more than one zone, then just add it in again as another row in the list and then specify a different zone for it. It's really, really very, very flexible. Right, so the next control or set of controls to talk about are these priority controls as we sort of moving from left to right across here. Now there are two algorithms where random choice comes in. R for random and P for polyphony. They're both randomly choosing instruments to play a note with, whereas S, sequential, it's always going to be the next one that it can choose, and U is going to be all of them. So P and R modes, they are random, but you can control how that random kind of works by giving instruments priorities if you want to. So if I turn off these two here, so we're only dealing with the top two. Let's just reset these zones, and that's easy to do. Just double click and they go back to being as they were, covering the whole range. Let's just go with these top two here. Now they're both mono synths. We're going to go with random mode, and there's a 50-50 chance of which one gets chosen. Alright, it's a 50-50 chance. But we can affect that random choice by setting priority. Now this priority goes from 1 to 100. It's like a percentage, if you like. Priority is both set at 50 right now. Now if I were to whack this one up to 100, now the priority of this one is twice as big as the second instrument, which means I'm now affecting that random choice, and I'm twice as likely to choose Pulse 2 rather than the Torres AS1. It's still random, but we are affecting the odds here. So it's just purely relative. You can go anything up from 100 all the way down to 1. Now obviously if I did this, then it's now 100 times more likely to choose Pulse 2 than the Torres AS1, so we'll probably never hear the Torres ever get played. Okay, so it's now time for a little bit more of an advanced class now with Polychain DIY. I want to talk about something which you don't need to worry about, but you might want to try it out because it really does give you a lot of power. Now, with some synth manufacturers, not that many, but with some synth manufacturers, when they provide polychaining in synthesizers, not only are they giving us some sort of like polyphony expansion capability, but they're also really giving us some cool features in terms of being able to minimize the amount by which you have to go around to every synthesizer that you're polychaining and adjust the front panels of them. And I'm thinking about the Prophet 6, the sequential Prophet 6. I did a video about this, which I'll give you a clip of here. But basically, as well as being able to polychain two Prophet 6s together, you can also, change the filter cutoff of the low pass filter on one of them, and automatically on the second synth, the filter cutoff will be adjusted, which means that you just have to use one synth front panel, fiddle around with controls, change the patch how you want to, and your polychained collection of synthesizers is all kept in sync. It's really, really brilliant, but not all synth manufacturers do this. Now, I thought about doing this in Polychain DIY, but the fundamental thing about Polychain DIY is that you can actually polychain anything, as long as you can play notes via MIDI on it from your computer, you can polychain anything. So I've addressed this sort of automation convenience capability, but it's not a comprehensive solution like you'd find with a sequential Prophet 6 as an example. Now the way I've done it is via a little file which I call a MIDI map file. I'm going to show you an example of one now on the screen. This is one I've just created for the Torais AS1. It's a little text file, that's all it is. It's just a simple little text file, one row which has got what we call in programming parlance a name value pair. We've got cutoff equals 102, resonance equals 103, filter EG equals 47, filter attack equals 50, etc, etc, etc. And basically what this file is doing is listing the MIDI CCs that you'd need to send to the synthesizer in order to automate that particular parameter. So if I want to automate the cutoff, the filter cutoff for a Torais AS1, the low pass filter cutoff that is, I'd send it a value with MIDI CC 102. Now you can use any text editor on your computer to create one of these things, but if you don't want to do that, if that sounds a bit technical to you, then I've got a shortcut for you. What we're going to see here is a little application that I've provided, will be available to you free with Polychain DIY. It's a MIDI map editor, and what you can do with this MIDI map editor is you can just whack the values in here. I'm using my mouse, dragging them down, set the MIDI CCs that your synth supports. These are the ones that I will use in Polychain DIY. You can automate cutoff, resonance, the amount that the filter envelope applies to the filter cutoff. We'll talk about pan later on. We've got the filter attack decay sustained release envelope, the amplitude attack decay sustained release envelope, and we've got some mod ones here. We'll talk about those later as well. They're also advanced things. But basically you just set the MIDI CCs in here and then you can save it as a file. Right, so we've got here the Pulse 2 and the Torais AS1 enabled. The other ones are disabled for the time being. We've got a MIDI map files loaded for each one, and what those MIDI map files are doing is telling Polychain DIY, well, if you want to affect, say, the low pass filter cutoff, then this is the MIDI CC to use to change the cutoff on each of those synthesizers. So that's what's going on at the moment. Now, if we want to use a MIDI controller to affect the cutoff of both of those synths at the same time, then Polychain DIY needs to know what MIDI CC it's going to receive to affect the cutoff of the filter, if that makes sense. Now, normally on a MIDI controller, that's what you would dial in. You'd actually dial into your hardware controller a CC number because you'd be controlling one particular synth. Here we're controlling up to 8 synths at the same time, so you can choose whatever CCs you like. We just need to make sure that Polychain DIY knows what MIDI CC to receive, and we do that with exactly the same mechanism as we do before we use a MIDI map file. So I have got no, I say I don't actually have a hardware MIDI controller to demonstrate this with, so what I'm going to do is I'm going to use my Nord keyboard here, and I'm just going to use the mod wheel to adjust low pass filter cutoff, just to demonstrate this to you. Now, the mod wheel, the mod wheel generates MIDI CC number 1. That's a kind of a universal thing, right? So MIDI CC number 1. So what I'm going to do is I'm going to supply a MIDI map to Polychain DIY that says I want to change the filter cutoff, and I'm going to use MIDI CC number 1. That's what I'm going to do. I've actually got a little file. Where is it? This is what my MIDI map looks like. It's got one line in it. Cutoff equals 1. So that's saying filter cutoff MIDI CC number 1. And I've called this file mod wheel cutoff. So I'm going to choose here as an input a MIDI map, which is that mod wheel cutoff.txt file. So I've loaded my MIDI map input file. I've got my 2 MIDI map output files. It should hopefully work. So I'm going to go into unison mode here to start off with. So when I play a note, we'll hear both the synths, and then I'm going to move the mod wheel. Let's see if it works. It's controlling both of them at the same time. What I'll do is I'll go to sequential mode and just play notes sequentially and then move the mod wheel so I can prove that it's affecting both of them at the same time. And it works. It's as simple as that. Now obviously with my keyboard here, I've just got basically mod wheel. I don't have a bunch of controllers that I can use. I have to say I love the Nordwave 2. I'm going to do a video on it at some point, but it is not the greatest MIDI controller keyboard that was ever built. Let me show a different example. Now if you haven't got a hardware MIDI controller, I've provided a software MIDI controller just for you, just for use with Polychain DIY. Let me show you that now. So hopefully now you can see that, as well as Polychain DIY, as well as that editor for those MIDI map files. I've built a little software MIDI controller. And all you do is you just drag a cable, a virtual cable out of it and plug it in there. And we're still going to use the keyboard direct MIDI connection, but I'm going to use this to supply MIDI CCs so I can manipulate the filter, cutoff resonance, the EG amount, and the filter EG and the amplitude EG. If my synthesizers support those parameters, they may or may not. I haven't actually tried this on the AS1 before. We'll give it a go. So now I'm going to play some notes. Okay, that works. How about the resonance? Okay, so now we've got MIDI maps out of the way. There's an extra sort of capability that MIDI maps give Polychain DIY, which I want to talk about next, and that is something called pan spread. Now, pan spread is something that you find on just some synthesizers. They obviously have to be stereo synthesizers, but it's that beautiful sound where you turn up a dial or a slider, and the voices start to spread wider and wider and wider in the stereo field. It's there on the Prophet synthesizers, for example. It's a wonderful, well, the stereo Prophet synthesizers. It's a wonderful, wonderful effect. It really is fantastic, and I wanted to try and implement it in Polychain DIY. So now we have MIDI maps, and we have the ability to tell Polychain DIY what MIDI CCs to use in order to automate different things like filter cutoff and resonance and stuff like that. Now, if your synthesizer, first of all, is a stereo synthesizer, secondly, it accepts MIDI CC automation, and thirdly, it has a MIDI CC specifically for panning a voice, then you can put that into your MIDI map and you can use pan spread on the Polychain DIY, which is what I'm going to show you now. Now, what I'm doing here is I'm connecting up Polychain DIY to my Waldorf Kyra, which I haven't featured in a video for a very long time. It's an incredibly powerful, wonderful sounding synthesizer. The user interface is a little bit of a pain, but it's a multi-timbral synthesizer. It's got 8 parts to it. And what I've realized and what I've discovered using Polychain DIY is that polychaining multi-timbral synths is an incredibly fantastic, powerful, loads of fun and very creative thing to do. It's not just about picking different monosynths and putting them together as if they're a polysynth, but actually being able to play and control the individual parts of a multi-timbral synth is hugely fun. It really is. What I'm going to demonstrate this pan spread with is the Kyra, and the reason I'm choosing it is because it is a stereo synth. It is able to be automated using MIDI CC automation, and thirdly, it has a MIDI CC specifically for setting the pan position in the stereo field of its parts. So what I've got going on here on the Kyra is I've got the same patch, a very simple sawtooth patch, the same patch on each of the 8 parts to my multi-timbral setup that I've got going on here. So if I just play through them one note at a time in sequential mode, you'll hear that we get the same sound. Okay, and they're all central in the stereo field. A little bit of reverb going on, I think, but they're central. And I'm going to turn up this pan spread control. Now, when I turn up this pan spread control, what Polychain DIY is going to do is, for any of the instruments that support a pan MIDI CC, it's going to send MIDI CC values to each of the instruments before it plays a note with them, and it's going to set the stereo panning of those parts. And this is what it sounds like. In fact, I'll just play a little arpeggio. See how it brings it to life, widening, widening, widening. Now, there are 3 algorithms that I've provided here regarding pan spread. This topmost one is the most extreme. As you turn up the dial, it's a ping-pong effect, left, right, left, right, left, right, and it widens, 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 and widens, and widens. Let me play some chords, and I'll bring it back down. It's a ping pong. Now that's what that first algorithm is. The middle algorithm is also a ping pong in terms of where it places the voices in the stereo field, but where it places the voice has got a sort of amount of randomness to it. So it won't always be at the extremes, it'll be somewhere between center and the extremes. So a little bit more random, a little bit more natural, but a much more subtle effect. So let me play that one to you next. And then finally, the lowest position of the switch. This is the maybe the most subtle of them all. Again, it's got this randomness as to whether to where to place in the field. It could be in the center or anywhere between there and the extremities that you specify with the rotary control. But it's not ping pong. Which side it chooses is also a random choice as well. So the first thing it does is say, well, which side should I pan? Chooses that randomly, and then how much should I pan? It chooses that randomly between 0 and the extremity that you set with the dial. So it sounds like this. Okay, just a couple more things to cover as we're going through everything on the user interface. So very, very quickly here, this little button here, it's an all notes off button, because there's going to be times when you're playing around with the screen that you might well end up having a hung note, a note that just keeps on playing on one of your synths. You know, you can just be changing the channel number or changing the MIDI device at any point in time, and if you've got any notes playing at that time, you're going to get hung notes. So this will send an all notes off message to everything that's connected. Obviously, if you've disconnected your synth, it won't be able to send an all notes off to it. It can't work miracles, but it's there in case you need it. The other control or set of controls I want to talk about now is these sustain controls. Now, I need to give you a little bit of sort of background to this, because Polychain DIY is taking control of voice allocation for you. It knows how many voices you've allocated to each of your instruments. It knows when you play a key, when you hold down the note. It knows when you let go of a note. So it's completely in control of which notes get sent to which synthesizers. It knows when a synthesizer, an instrument, has run out of free voices. It knows when it has to go and steal one. It chooses which instrument to steal from. All of that logic is what is inside Polychain DIY. Now, all that logic goes to pieces when you start using a sustain pedal. Because when you start using a sustain pedal and you hold down the pedal, when you take your fingers off the notes and you release the keys, the notes carry on playing. The synths still keep on playing those notes. And at that point, Polychain DIY kind of loses control of its voice management for you. It really can't manage the voices anymore. It can't predict what your synthesizers, your instruments are going to do in terms of receiving more notes. It can't basically, when you've got your sustain pedal down, it can't force a synth to stop playing a note so that it can play another one. So all the time that there are some free voices for it to choose from, it doesn't have to do any voice stealing. It's fine with you holding down the sustain pedal, but as soon as you hold down the sustain pedal, it can't voice steal anymore. It just doesn't have the capability. It just doesn't know enough about how the synths are going to react, and it can't take back notes from those synths. So that is the limitation. Obviously, if you've got plenty of free voices, depending on your style and how you're playing, whether you've got polysynths involved or not, it's unlikely to be a problem. But if it is a problem, then this little switch here will turn on or off sustain message sending to your instrument. So by default they're all on, which is the upward position. Here what I've got going on, so I can show this as an example, I've got the Jupiter XM. I've set the voice count to 64, so there's oodles of voices there for me to play. And I've got a zone going on, so it's stopping at G5, basically, at G5. So from G flat 5 downwards, I'm going to be playing the Jupiter XM polyphonically, 64 notes. The Pulse 2 I've chosen as a monosynth to play from G5 upwards, and it's only got one note at a time. It's a monosynth, or it's in monosynth mode. Now I've got sustain pedal working for the Jupiter XM because we've got loads and loads of voices, and we're unlikely to ever run out of free voices. But with the Pulse 2, I'm going to be holding down the sustain pedal a lot. So let me just show you the kind of thing you can do. I'm going to hold down the sustain pedal, play the Jupiter XM. It's sustaining. And I can play the Pulse 2, no problem. Okay, so here is an example of using Polychain DIY to control soft synths. That's synthesizers, sample libraries that are acting as a VST inside your DAW. To do this, you need to have Polychain DIY running inside your DAW too. So I'm showing you here Cubase, which is the DAW that I have. It's the one that I know. All the major DAWs work the same way, so hopefully you'll be able to see what I'm doing here and adapt it to your particular DAW if you don't use Cubase. And you'll see here that I'm actually recording as I am showing you this, because actually I used Cubase to record my microphone. So that's why you're seeing things scrolling along there. Now what I've got here, I've got a voltage modular running as a VST instrument inside Cubase, which you can see over here, and I've loaded Polychain DIY into it. And then I have got 3 copies of a sample library that's just come out from Spitfire Audio. It's a very nice, sort of gentle little sample library. It's very, very cheap. It's called Think Signatures. It's basically acoustic guitar sample library. So I've got it here running 3 instances of it. It's very, very lightweight, doesn't take up much memory, so it's really nice to use. And what I'm going to do is I'm going to polychain these 3 instances. Now the way that I have to do that or set that up inside Cubase is, the first thing you'll need to do is you'll need to drag a cable from this top MIDI DIN socket inside Voltage Modular to Polychain DIY. This is labeled from host, so any MIDI coming from the DAW that's fed to Voltage Modular comes out of this socket. So I'm feeding that in. So I'm not going direct to my keyboard inside Polychain DIY. I'm using the DAW's MIDI. So, if I were to record some sequences or record some notes in the DAW and play them back, I'd get them through this cable, this virtual cable, the same way as if I'm playing interactively, which is what I'm going to do. So that cable needs to be there. Secondly, what I've done is I've created 3 instrument channels. You see the 3 ones enabled here. And the MIDI out of all my MIDI devices, there's one here near the top called toHost. And what that does is it will divert MIDI back into the DAW from Polychain DIY. So I've got it set to toHost on all 3 of the instruments, but I am differentiating them by setting them to different MIDI channels. So this first instrument I'm going to send back to the DAW on channel 1, this one back to the DAW on channel 2, and this one back to the DAW on channel 3. So that is how I've set up Polychain DIY to send MIDI back into my DAW on a specific channel. Now in Cubase, how I then use that MIDI is if I select the first of my sample library plugins that I'm going to be polychaining, here is where I set the MIDI input to it. You can see I can set it to various ones, including the keyboard itself, but I can actually use the MIDI output from another instrument. So voltage modular itself is registered in Cubase as an instrument that can give out MIDI, so I can use that MIDI and route it into my VST synth plugin, or my sample library plugin, and I've done that for each of them. So you'll see each of them has got voltage modular MIDI output as its input. So that's how we route the MIDI from Polychain DIY back to the DAW and into each of the VST synths sample libraries that I'm going to play. Now, how do we make sure that they play on the different channels? Well, what we need to do is make sure that the channel here is any. So it's not going to be a specific channel. It's just going to be the raw MIDI data that gets passed in without affecting the channel. And then inside the VST plugins themselves, you'll see here there is a MIDI channel selection, which by default was set to any as well, but I'm setting this one to number 1. This one is number 3, this one is number 2. So I got them around the wrong way, but there you go. 1, 2, and 3. So they're all listening to their own MIDI channels. And so the only thing I need to do with voltage modular is give it an input, which will be my keyboard. So I've set the input for voltage modular to be my Nord Wave 2. So it all should work. Hopefully it should work. So I've got the algorithm set to sequential, so we'll play one note at a time, and we should hear each of these instruments play. They're all playing subtly different guitar pluck sounds, and it sounds like this. Can't really hear what I'm doing, so I'm going to put my headphones on. So at the moment they're all set to just a voice count of 1, which is not really very practical, so let's up that so that we get some ringing out voices if you want to hear them. So that's it, that's Polychain DIY. It started out as a solution to a simple problem, and that problem is how can I play a bunch of different synths at the same time in creative ways from using just a simple basic keyboard. Polychain DIY is a lot more than just a MIDI controller or a MIDI controller keyboard. It goes way beyond what MIDI controller keyboards can do. Yes, you've got zones, but you can have unlimited zones. How you want to define them with crossovers, all the rest of it, it's entirely up to you. How you transpose your instruments within those zones is entirely up to you. And of course, you've got polychaining. You've got the 4 different Polychain algorithms. You have got automation in terms of pan spread, in terms of modulations, polyphonic expression modulations that you can feed into your instruments, as well as being able to control all your instruments if they support MIDI automation via MIDI CCs. all the basics of filter cutoff, resonance, filter envelopes, amplitude envelopes, etc. You know, in the high-tech world in which we live, we're constantly under pressure to buy new gear. It's a constant pressure upon us, and it becomes an addiction. And what I've tried to do with Polychain DIY, and it's the same with my other software-based MIDI controller applications, I'm trying to provide tools that help us get more from the gear we own. That's it. Until the next one, as always, thank you very, very much for watching.